Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2022, Paper 2, Variant 2. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding and also you can have better understanding of these questions and also better understanding of this topic. In order to get maximum benefit from these videos, the best way is to pause the video, do questions by yourself, and then check your answers with my solution. If you follow this, you will improve yourself quickly and you will have better understanding of physics. Let's study together, let's improve together. In today's class, we are talking about October-November 2022, Paper 2, Variant 2, and total time for this exam is 1 hour and 15 minutes and total mark for this paper is 60. You need to answer all the questions on this paper. On second page of exam paper, you can also find values of some constants and maybe you need value of some constant for some calculations in your exam. So if you need value of any constant, you can come to this page and you can find the values. It's very important to understand that values of some constants are given to you and you can find those values on second page of your exam paper. Let me highlight the constants you need for AS physics. For AS physics, you need these constants. So maybe you will see some of them on your exam paper. So if you can remember values of these constants, it's wonderful because as a physics student, it's important to remember these constants. If you have forgotten any value of any constant, then you can come to this page and you can find the values. On second page of exam paper, some important formulae are also given to you. But these are not all the formulae you need for AS physics. So it's very important that you remember rest of the formulae or you need to understand how to derive them. Because when you derive a formula, you understand the physics behind that. And that is what you need for understanding of physics. So try to derive formulae by yourself. But if you have forgotten any formula, you can come to this page and you can check for that formula. For question number 1, part A, we need to state what is meant by work done. A typical type of question, you need to understand how to state this. Work done simply is equal to the product of force and displacement. And displacement has to be in direction of force. So simply we can say W is equal to Ft. W is equal to Ft. So work done is the product of force and displacement in direction of force. So this is how you can write down your answer. So this is what you need to write down for the answer of this question. Let's move on to the second part. For part B, we need to use the answer to A to determine the SI base units of power. SI base units of power. So first thing we need to understand how power is linked with work done. Power is simply equal to work done, P for power. This is simply equal to work done over time. So we can write down power is equal to work done over time. And work done is equal to force time displacement over time. And now we can write down SI base units for the force. Force we can also write down. This is equal to MAD divided by T. Now we can write down SI unit. SI unit for mass is kg. So SI unit for mass is kg. And SI unit for acceleration is meter per second, and for displacement is meter, and for time is second. Now we can simplify this one. So we can write down this is kg meter square, and we have s to the power of -2, and we can write down s to the power of -1. So finally we can write down this is kg meter square, s to the power of -3. So this is SI base unit for power. Kg meter square, s to the power of -3. This is how you can derive SI base unit for power. For part C, it is given to us the maximum useful output power P of a car traveling on a horizontal road is given by P is equal to V cube times P. V is the maximum speed of the car and B is a constant. For the car, we have value of P, we have value of V in SI units, and we need to calculate value of V. So we need to calculate value of V, so we can make V the subject answer. So we can say V cube. This one will be equal to P divided by P. As we need to calculate value of V, so we need to take cube root on both sides. So simply we can take cube root on both sides. Now simply we need to plug in values. Value of P is given, that is 84 kilowatts. So this is 84 kilowatts divided by value of P, that is 0.56, and we need to take cube root of this one. Cube root simply means 1/3. And now if we solve this one, our final answer up to 2SF will be 53 meters per second. So this is the speed of the car, and this is our final answer up to 2SF. For the second part, we need to determine the absolute uncertainty in the value of V. But V is given to us, and V is equal to P/P to the power of 1/3. So we need to calculate absolute uncertainty in the value of V. So first of all, we can calculate the percentage uncertainty in V. Percentage uncertainty. So the percentage uncertainty in V has to be equal to the percentage uncertainty in P plus percentage uncertainty in P, and this has to be multiplied by 1/3 because the power of this one is 1/3. So we have to multiply by that. Percentage uncertainty in P is given, that is 5%. So we can write down this is 5%, and percentage uncertainty in B is 7%. So here we have 7%. So we need to add, then we need to divide. So we will get in this case 12. 12 divided by 3, it means we will get 4%. So this is percentage uncertainty in V. And so now simply we can write down delta V by V, the percentage uncertainty in this one. This is equal to 4%. Mean this is equal to 4. So we need to find in this case delta V. Delta V simply will be equal to 4 divided by 100 multiplied by V, and value of V we have already calculated in part 1. So we can say this will be equal to 0.04 multiplied by 53. So in this case, our final answer up to 1SF will be equal to 2. So simply we can write down this is plus minus 2 meters per second. Because absolute uncertainty, we have to write using 1SF. So that's the reason we have written this one up to 1SF. And this is our final answer. For question number 2, it is given to us a spherical balloon is filled with a fixed mass of gas. The small block is connected by a string to the balloon as shown in figure 2.1. The block is held on the ground by an external force so that the string is vertical. The density of the air surrounding the balloon is 1.2 kg per cubic meter. The upthrust acting on the balloon is 0.071 newtons. The upthrust acting on the string and block is negligible. We need to use Archimedes principle, and we need to calculate radius of the balloon. So for this question, upthrust is given to us and density of the fluid is given. So simply we can start with upthrust. So simply we can say in this case upthrust, this is equal to density of the fluid times G times volume of fluid displaced. But in this case this balloon is inside the air, means the volume of fluid displaced is equal to volume of balloon because this is fully submerged. So we can say this is density of the fluid and this is the volume of fluid displaced. So we can also write down here this is volume of fluid displaced. So it's better to understand upthrust. This formula is very important. Now simply in this case we can plug in values. What values are given to us? We have value of upthrust, that is 0.071, and density of the fluid is given, that is 1.2, and value of G is 9.81. So here we can simply write down V. This is volume of fluid displaced, V. We need to calculate radius of the balloon. So we can little bit rearrange. We can write down volume in this case will be equal to 0.71 divided by 1.2 times 9.81. So from here we can get value of volume. But we need to calculate radius of the balloon. So we can write down formula for radius of the balloon. This is spherical in shape. So simply we can say this is 4/3 pi r cube, and this will be equal to 0.071 divided by 1.2 times 9.81. Now we need value of radius, so simply you can cross multiply. So in this case we will have 0.071 times 3, and this one will be divided by 4 pi times we have 1.2 times 9.81. We need value of r, so we have to take cube root on both sides. And now you can calculate value of radius, and value of radius in this case will be equal to 0.11 up to 2 SF. So this is value of radius, and this is how you can calculate. So the final answer up to 2 SF has to be 0.11. In this case we need to understand, because raw data, it has least number of SF, that is equal to 2 SF. So this one has 2 SF, this also has 2 SF. So that's the reason our final answer we have also written using 2 SF. For part B, it is given to us the total weight of the balloon, string and the block is 0.053 newtons. The external force holding the block on the ground is removed so that the released block is lifted vertically upwards by the balloon. Calculate the acceleration of the block immediately after it is released. So in this case, simply question is asking us acceleration. So we need to understand the net force acting on the block vertically upwards. So we need to find out that net force, and then we will divide that net force by mass of the balloon, string and the block, and we can find out value of acceleration. So first of all, let's look at forces acting on this balloon. There are two forces acting on this balloon. So one force is acting vertically down, that is the weight of the block, string and balloon, that is given to us. So we can write down here 0.053 newtons. And up thrust is acting on the balloon. Up thrust in this case is greater than the weight. So that's the reason this balloon will accelerate vertically upwards. And value of up thrust is given. We can say Fu. Up thrust is given, that is 0.071 newtons. And we need to find the acceleration. So simply in this case, acceleration will be equal to F net divided by mass of the system divided by m mass of the system. I mean this balloon, string and block system. F net simply we can find out from here, that will be equal to 0.071 minus 0.053, and we need to divide by the mass of the system. But weight of the system is given to us, weight of the system. So we can calculate mass of the system, mass of this system. Mass will be equal to weight divided by 9.81. So we can write down weight divided by 9.81. Weight is 0.053 newtons divided by 9.81. So in this case, we will get value of mass, that will be equal to 5.4 times 10 to minus 3 kgs. Means 5.4 grams we will get. So simply we can plug in this value here now. It has to be in kgs. 5.4 times 10 to minus 3 kgs. So we can find out value of acceleration. That will be equal to 3.3 meters per second up to 2 SF. Because in this case raw data is given up to 2 SF. So we will consider least number of SF in given data. That's the reason our answer has to be up to 2 SF, and this is our final answer. It's very important when you write down your answers in exam, write down all the steps, because if your answer is wrong but you have done the right steps, still you will get C marks. So always write down all the steps. For part C, it is given to us the balloon continues to lift the block. The string breaks as the block is moving vertically upwards at a speed of 1.4 meters per second. After the string breaks, block briefly continues moving upwards before falling vertically downwards to the ground. The block hits the ground with a speed of 3.6 meters per second. Assume that a resistance on the block is negligible. We need to consider motion of the block after the string breaks, and we need to calculate the height of the block above the ground when the string breaks. Very nice question, and is a typical type of question. You will see this one in many past papers. You will see this type of questions in paper 1. You will also see same type of questions in paper 2. So understanding of this question is very important. First of all, we can draw the ground here. Imagine that this one is the ground. So this one we can imagine, this one is the ground. And the string breaks when the block is at this point. So we can also draw this line here. It means the string breaks at this point. And the speed of the block and balloon at this point is given. The initial speed is given to us, that is equal to 1.4 meters per second. So simply we can label this one 1.4 meters per second. It is also given to us the block goes upward. Even it is not given in the question, you need to understand this block at this point will not stop because it has velocities. It will continue moving upwards. It will reach a maximum height. So block will go like this. It will reach a maximum height, and at this point its speed will be 0, and we can say this is u, and you can say this is v at the top. At the maximum height v will be 0, and after that this block will start falling downwards. So it will hit the ground, and the speed when it hit the ground, that is given, and that speed we can say is v. V is equal to 3.6 meters per second. And for this question we need to find out this height. Means this height we need to find out. Question is asking us to calculate height when the string breaks. So this height we need to calculate. And also we need to understand it is given to us a resistance is negligible. So there is only one force acting on this block, and that is gravity. So simply we can say acceleration of this block will be equal to g, because only one force is acting on this one, and that is gravity. So we can say this is 9.81 meters per second per second. So we have initial speed, initial velocity, we have the final velocity, and we have acceleration. So we can find out displacement. In order to calculate displacement, we can simply use v squared minus u squared. This is equal to 2as. We need to find displacement. So s will be equal to v squared minus u squared divided by 2a. But we have to be very careful in this case, because we have direction of u up, direction of v down, and direction of a is also down. So in this case we will take down is positive. So we will take down is positive. So our displacement will be positive. You can also take up is positive. So your answer will be negative. So in this case we will take down is positive. If we take down is positive, so we can say this velocity will be negative. This one will be positive. Acceleration also will be positive. So now we can plug in values. Value of v we have, that is 3.6 square, and we have value of u, that is minus 1.4 square, and this is divided by 2 times value of g, that is positive 9.81. So if we solve this one, we will get our final answer, that will be 4.56, and this answer will be positive because displacement is down and we have taken down is positive, so you will get positive answer in this case. If you have taken up is positive, the answer will be negative. And so the final answer for this question is 0.56 up to 2SF, because raw data has least number of SF, that is equal to 2SF. So this is our final answer, and this is how we can approach this type of problems. Typical type of question, we can also use log method, but this is a smart way to answer this question. For the second part, it is given to us the string breaks at time t is equal to 0 and the block hits the ground at time t is equal to capital T. On figure 2.2, we need to sketch a graph to show the variation of the velocity v of the block with time t from t is equal to 0 to t is equal to capital T. Numerical values of t are not required. Assume that v is positive in the upward direction. So it simply means that we need to take upward direction as positive. And we have value of u, that is equal to 1.4 meters per second, and this is vertically upwards. And we have value of v, that is equal to 3.6 meters per second, and this is vertically downwards. And acceleration in this case is equal to 9.81, means is equal to g, and that is equal to 9.81 meters per second, and this is also vertically downwards. And so we have taken up is positive. We have to take up is positive because question said up is positive. So this value will be positive, this one will be negative, this value also will be negative. We also need to understand the gradient of velocity against time graph is equal to acceleration. So in this case, acceleration is equal to negative 9.81. It means the gradient has to be negative and the magnitude of the gradient has to be equal to 9.81. Now based on this one, we can write down the coordinates. So we have time t that is equal to 0. We have value of u that is equal to 1.4. And when t is equal to capital T, we have value of v that is equal to negative 3.6. We can also write down the units. These are the units. Now simply we have to take these points on the graph and we can sketch. So we have to take 0, 1.4, 0, 1.4. So it will be here. So we can write down this is 0, 1.4. And the coordinates of this point we can also write down. So at this point we will have capital T, negative 3.6. And now we need to draw a line and we need to connect these points. So simply you can draw a line like this. So this is what you need to draw for this question. If you sketch this line with negative gradient with these coordinates, you will get 2 marks. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from October-November 2022, paper 2, variant 2. In today's lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions and also these topics. Let's study together. Let's improve together. For our third question, part A, we need to state what is meant by the center of gravity of an object. Center of gravity of an object is very important point and it has many applications in real life and also it plays very important role in designing a lot of equipment. So what is center of gravity? Center of gravity is a point where all the weight of the body can be considered to act. That point we call is center of gravity. Center of gravity we can also define in a little bit different way. Center of gravity is a point through which a single force will create no turning effect. So let's try to find out center of gravity of this pen. So I will slide my finger under this one. You see, if I apply a single force here, there will be turning effect. It will go this way. So I will slide under this one. I will reach a point. And if I apply a single force at that point, there will be no turning effect. And that single point is this one. So you can see at this point, I'm applying a single force that is acting vertically upward and there is no turning effect. So this is center of gravity of this pen. Center of gravity, it can be outside of the body, it can be inside the body. Now let's go back and try to write down answer for this question. This is how we can write down answer for this question. Simply you need to say that is a point where all the weight of an object is taken to act, or you can say is considered to act, and that point is center of gravity. And for this 30 centimeters meter rule, you can see its center of gravity is located at 15 centimeters because its density is uniform. If the density is uniform, it's a uniform meter rule. It simply means that center of gravity and the midpoint of the meter rule, they will be at the same point. So center of gravity, in this case, if it is the uniform meter rule, means its density is uniform. So center of gravity will be at midpoint of that object. Midpoint will be at midpoint. So in this case, it is at the midpoint because it has a uniform density. Simply you can say this is a uniform meter rule. For part D1, we need to calculate the vertical component of the force exerted by the wire on the beam. So this is the wire. So wire is exerting force of 45 newtons at an angle of 37 degrees with horizontal. We need to find out its vertical component. So simply we can resolve this one into vertical component and also we can resolve into horizontal component. So it has vertical component and it has horizontal component. For this question, we need to calculate its vertical component. So this component will be horizontal, this one will be vertical. So this is simply 45 cosine of 37 degrees and this one will be 45 sine of 37 degrees, and this is simply what we need to write down. So we will say vertical component in this case, vertical component vertical component of force in this case will be equal to 45 sine of 37 degrees, sine of 37. And if we solve this one, our answer will be 27 newtons up to 2 SF. So this is our final answer. So this is how you can find out. For the second part, we need to calculate the weight W of the block by taking moments about it. So simply we need to take moments about this point, and sum of clockwise moments has to be equal to sum of anti-clockwise moments because this beam is in equilibrium. And also it is given to us that this beam is uniform. So it simply means that its center of gravity is at its midpoint. So the distance from the wall to this point, if we draw a dotted line here, we can say this distance is equal to 0.48. So this distance is equal to 0.48. We can simply draw a dotted line here from this wall to the center of gravity. So this distance is 0.48. So this is 0.48 meters because total length of the beam is 0.96. Now there are three forces. Weight is acting here and this distance is 0.56. So this will be 0.76. And there is a force due to this wire, and we can resolve that force into components, vertical and horizontal. So this is the vertical component. Due to vertical component of this force, there will be moment, but there is no moment due to horizontal component, because horizontal component is simply passing through the pivot point. So we can draw horizontal component here as well. Now simply we need to take moments. Moment due to weight of the beam, this will be clockwise. Moment due to this weight of the block, this also will be clockwise. But moment due to vertical component of force due to this wire, this one will be anti-clockwise. Now simply we need to equate clockwise moment and anti-clockwise moment. First of all, we can write down for this weight of the beam, this is clockwise, so 23 times we have 0.48 plus we have this clockwise moment, that is W, times 0.56 plus 0.20, it means this is 0.76, and this one has to be equal to moment due to vertical component. Vertical component we have calculated, that was 27 times this distance, that is 0.56. So this is 0.56. Now simply we need to solve for W, and our answer in this case will be equal to 5.4 newtons up to 2 SF. So our answer is 5.4 newtons. So this is how you can figure out. For our third part, it is given to us the hinge exerts a force on the beam at end A. Calculate the horizontal component of this force. So first of all, we need to understand, as this beam is in equilibrium, it simply means that the sum of the forces along horizontal has to be equal to 0, and sum of the forces along y-axis also has to be equal to 0. So now simply we'll need to look at horizontal component of the forces. In this case, this force has no horizontal component. This force has no horizontal component. Only force due to wire, this one has horizontal component. And direction of horizontal component is to the left. So in order to balance this one, there must be horizontal component of force due to hinge at this point, and that one has to be to the right. And these two components, they have to be equal in magnitude but opposite in direction. So it simply means that the horizontal component of hinge force, we can say FH, that one will be equal to 45 cosine of 37 degrees. So that's all what you need to understand. If we solve this one, your answer will be 36 newtons up to 2 SF. So this is our final answer. Now if we go to the next part, part 4, the block is now placed closer to point D. Closer to point D means we move this block this side. So imagine that this block is placed here now. So we move this one to the left. State whether this change will increase, decrease, or have no effect on the tension in the wire. But we need to understand, in this case, the beam is still in equilibrium. Still in equilibrium. So first thing, we need to look at the moments. Moment due to weight doesn't change because force is the same, distance is the same. Moment due to W, due to this W, it has decreased because this is the same, but this distance has been decreased. So the moment due to this weight of the block has been decreased. Now we need to look at moment due to vertical component, or simply we can say moment due to force in this wire, and that distance doesn't change, means the distance of force from the pivot, it doesn't change. So it means this force has to decrease. Because this distance decreased, so this force has to decrease, because the distance of this force from the pivot does not change. So it simply means that in this case, tension in the wire, it will decrease. So simply you can see from here, tension in the wire has to decrease because this distance has been decreased. So the moment, net moment, has to be equal to 0. So this force has to decrease in magnitude. So simply in this case, we can say tension in the wire decreases. Tension decreases, or you can say tension in the wire decreases. So this is how you can approach this problem. For part 5, it is given to us the stress in the wire is 5.3 times 10 to 7 Pascal. The wire is now replaced by a second wire that has a radius that is 3 times greater than that of the original wire. The tension in the wire is unchanged. Calculate stress in the second wire. So quite straightforward question. Radius has been increased by 3 times, but tension is the same. So it means that area has been increased by 9 times. So stress will decrease by 9 times. So simply this is how you can answer. So let me explain you this one step by step, because this question has 2 marks, so you need to write on this one in a proper way. So the first thing we need to understand, stress, simply stress, this is equal to force over cross-sectional area. In this case, force is the same. Force is same. So we can also write down sigma for stress. We can say this is equal to force over cross-sectional area. In this case, F is the same. So we can say the product of stress and cross-sectional area for 2 wires is the same. So this one is constant. So simply we can say this one is constant. So we can write on here. And so we can simply say in this case sigma 1 A1, this one has to be equal to sigma 2 times A2. So we can change this here. Area, we can write on this is pi r square. We can say r1 square. And here we have this is value of sigma 2. And we can write on this is pi r2 square. But in this case, r2 is equal to 3 times of r1. So we can rewrite this one. So we can write on sigma 1. So we have here sigma 1. Here we have pi r1 square. This will be equal to sigma 2, and here we have pi, and this is 3r1 square. And so we will get here this is sigma 1, and here we have pi. You can simply cancel with this one. So we left with r1 square, and here we have this is sigma 2. So we can write on sigma 2 here, and we will have 9 times r1 square. So r1 square, we can simply cancel. So from here we can get sigma 2, that will be equal to sigma 1 divided by 9, and sigma 1 is given to us. The value of sigma 1 is given, that is equal to 5.7 times 10 to 7. Just simply divide by 9 and we can find our final answer. Final answer in this case will be equal to 5.9 times 10 to 6 Pascal. Actually this is 5.3. Sigma 1 is 5.3 times 10 to 7. So this is our final answer, and this is how you can figure out 5.9 times 10 to 6 Pascal up to 2SF. So this is how we can approach. This question is very straightforward one, because in this case F is same. So if this increased by 9 times, this one has to decrease by 9 times. So simply you have to divide this stress by 9 and you can find the final answer. For our question number 4, it is given to us a horizontal spring is fixed at one end, a block is pushed against the other end of the spring so that the spring is compressed as shown in figure 4.1. And it is also given to us the block leaves the end of the spring with a speed of 2.3 meters per second as shown in figure 4.2, and mass of the block is given, that is equal to 250 grams, and spring constant is given, that is equal to 420 newtons per meter. It is also given to us the spring obey Hooke's law. For part A, we need to calculate the kinetic energy of the block as it leaves the spring. So quite straightforward question. We have speed of the block and we have the mass of the block. So simply you need to use kinetic energy formula. Ke is equal to 1/2 mv square. It is very important you write down the formula because it has marks. So always write down the formula, then plug in values and then do calculations. And then you can write down your final answer. Kinetic energy we need to calculate in this case. So simply this is 1/2 and the mass is given in grams. So we can convert into kilograms. So this is 0.250 and speed is given in SI base unit. So simply you can write down this is value of speed. And now if you do calculations, in this case our final answer will be 0.66 joules up to 2 SF. Because raw data, the least number of SF in raw data is 2 SF. So our final answer also should have 2 SF. So this is final answer for this question. For the second part, we need to calculate the compression of the spring immediately before the block is released. So it simply means that first of all, we compress the spring, we move this block to the left. So imagine that spring is fully compressed when the block is at this point. And question is asking us to calculate this amount of compression because at this point the block is leaving the spring, means the spring is fully extended at this point. So we need to calculate value of x. In order to calculate value of x, at this point when the block is here, spring is fully compressed. So the energy stored in this system is equal to EPE. And at this point, the spring is not extended and not compressed. So the energy in the system is stored in form of kinetic energy. So simply in this case, we can say elastic potential energy. This is equal to kinetic energy. And kinetic energy we have already calculated. We have the value of kinetic energy. So EPE, we can say this is 1/2 K times x squared. And kinetic energy we have already calculated. That was equal to 0.66. So in this case, it is also given in the question that all the EPE has been converted into kinetic energy. So in this case, there is no loss of energy due to friction. We need to calculate in this case value of x. So we can rearrange this one for x. So we can write down in this case x square. This one will be equal to 2 times 0.66 divided by k. So this is k. We need to calculate x. So we have to take square root on both sides and we can also plug in values of k. K in this case is equal to 420. So if we take root of this one, 1/2, we can find value of compression and compression will be equal to 0.56 meters up to 2 SF. So this is our final answer. So we can write on here 0.056. So this is the final answer. For part C, it is given to us after leaving the spring, the block moves along the surface until it hits a barrier at a speed of 2.3 meters per second. The block then rebounds at a speed of 1.5 meters per second, moves back along its original path. The block is in contact with the barrier for a time of 0.086 seconds. We need to calculate change in momentum of the block during the collision. So simply we can imagine that there is a barrier. So you can simply imagine here is a barrier and this block hit this barrier with speed 2.3 meters per second and rebound with a speed of 1.5 meters per second. We need to calculate the change in momentum of the block. In order to calculate change in momentum of the block, simply we can say delta P. This will be equal to m times v minus u. In this case, mass of the block is 0.250 kilograms and the final speed. So we need to take one direction as positive because momentum is a vector quantity. So we will take in this case to the left positive. So our answer will be positive because to the left is direction of resultant force. And so we will take to the left positive. So our answer will be positive. So it simply means that this value is positive and this value is negative. So simply we can plug in values. We have 1.5 minus into we have minus 2.3. Now if we solve this one, our final answer in this case will be equal to, let me write on one more step. So we will get 0.250, and here we will get 1.5 plus 2.3. And if we solve this one, our final answer up to 2SF will be equal to 0.95 newtons second, because this given unit is Newton seconds, so this is 0.95. And this is how you can approach. Only tricky part in this question is direction. Momentum is a vector quantity, so you need to take one direction as positive. And change in momentum, direction of change in momentum is the same as direction of change in velocity. So in this case, resultant force on the block is to the left, so we have taken to the left positive, so our answer is positive. If you take to the right positive, your answer will be negative, but magnitude will be the same. For the second part, we need to calculate the average resultant force exerted on the block during the collision, but we have already calculated change in momentum and the time of impact is given to us. So simply we can say, in this case, the average resultant force exerted on the block will be equal to the change in momentum divided by time of impact. So simply average resultant force is equal to rate of change of momentum, and change in momentum we have calculated, that was 0.95, and the time of impact is given to us, that is equal to 0.086 seconds. So if we solve this one, our final answer will be equal to 11 newtons up to 2SF. So this is our final answer. So this is how you can figure out average resultant force. For part D, it is given to us the maximum compression X of the spring is now varied in order to vary the kinetic energy of the block as it leaves the spring. Assume that all the elastic tension energy in the spring is always transferred to the kinetic energy of the block. On figure 4.3, we need to sketch a graph to show the variation with X of Ek. In this question, it is given to us that Ek is equal to EPE. So we can write down EPE in terms of X. EPE is equal to 1/2 kx squared. So we can simply say, in this case, Ek is directly proportional to x squared because k is constant and 2 is constant. So simply the shape of the graph has to be parabolic with increasing gradient. So when x is equal to 0, Ek also equal to 0. So gradient has to increase because it has to be parabolic. So this is how you need to sketch. So if you sketch like this, you will get 1 mark because this question has only 1 mark. For question number 5, part A, it is given to us two progressive sound waves meet to form a stationary wave. The two waves have the same amplitude, wavelength, frequency, and speed. State the other condition that must be fulfilled by the two waves in order for them to form a stationary wave. Two progressive waves, they can form a stationary wave if they have the same speed, they have the same amplitude, they have the same wavelength, and they have the same frequency. Only if these two waves, they are traveling in opposite direction, then they can form a stationary wave. So simply for this question, you need to write down travel in opposite directions. So those two waves, they have to travel in opposite directions. If they travel in opposite directions, they can form a stationary wave if they have the same amplitude, same wavelength, speed, and frequency. Travel in opposite direction. So we can say travel in opposite directions. For part B, it is given to us a stationary wave is formed on a string that is stretched between two fixed points A and B. Figure 5.1 shows the string at time t is equal to 0 when each point is at its maximum displacement. Distance AB is given, that is equal to 0.80. The period of the stationary wave is 0.016 seconds. For part B1, on figure 5.1, we need to sketch a solid line to show the position of the string at time t is equal to 0.004 second. Label this line P. Time 0.004 second. And this time, because in this case we have time period, that is equal to 0.016 seconds. So the time, this time 0.004 second, this given time, this time is equal to t by 4. So this is equal to t by 4. So this is first thing we need to understand. Now we need to understand where this string will be after t by 4. If you look at this particle, for example, after t by 4, this particle will be here. So this particle will go up and this particle will reach this point. And all the particles between these two nodes, they will reach this equilibrium. All the particles. I mean, if I take one particle here, this will go up. After t by 4, this particle will be here. And if I take particle here, after t by 4, this particle also will be here. And same is true for this node. This node and this node. So particle at the top, this will come back to equilibrium after t by 4. And it is also true for other particles in this loop, in between these two nodes. You can also take particle here after t by 4, this will come here. Because all the particles between two nodes, they are always in phase. If you look at this loop, mean between these two nodes, this node and this node, the particle at the bottom, after t by 4, this particle will be here, and particle on the string at this point, after t by 4, this will be here at equilibrium. And same is true for this one. We can also repeat this one. It's the same. So if you got this idea, that's wonderful. And particle here after t by 4 will be here because this particle go down. Particle here after t by 4, this one will be here. So it simply means that after t by 4, all the particles, they will be at equilibrium. So simply in this case, we can draw a line, solid line. So we will draw a solid line here. So this is what you need to do for this question. So you have to draw this line. So we have done this part. Now let's go to the next part. At time t is equal to 0.024 second, label this line Q. So this line we have to label P. So we can label this line is P. And now we go to the next one. We will answer next problem now. This one. Here we need to understand t is given to us. This t is equal to 0.024 seconds. We can write down this one in terms of time period. Time period is equal to 0.0016 plus we have 0.008. So this is t by 2. So we can simply say we have 1t plus we have t by 2. So this is the thing you need to understand. Now it simply means that after one cycle, this particle, let's say if we look at this particle, after one cycle, this particle will be at this point again because it will complete one cycle. It will go up and come back to this one. So after one cycle, what we will see, same wave we will see. Means we will see this shape of the string after one cycle. But now we need to understand this part. We need to understand t by 2. T by 2 means that after t by 4, this particle will be here, and after another t by 4, this particle will be at the peak at this point. Particle will reach at this point because it will take t by 4 to reach equilibrium, then again t by 4 to reach this peak. So this particle will be here. So we can draw here. And this particle after t by 4, it will be here, and after another t by 4, this particle will be at this trough, lowest point. And this particle t by 4 here, another t by 4, this particle will be here at this point. And this particle after t by 4 here, after another t by 4, this also will be at the lowest, it means at the bottom here. Now simply we need to connect these points. And to connect these points, we will use pink color. So particle here, it will just stay here. Particle here, this is at the node. This particle will not move. This particle will not move. This particle will not move because its displacement is 0. So simply we need to connect these. So we can simply connect like this. So we can connect. So this is what you need to draw. And this wave is Q. So we will say this one is Q. So this is how you need to label. I hope this one is clear to you. Beautiful question about stationary waves. So if this question is clear to you, it means you have good understanding of stationary waves. So you need to understand particle between any two consecutive nodes, they are always in phase. And particles on the two sides of any node, they are in antiphase. So when this particle is moving up, this particle will be moving down because they are on two sides of the same node. And same is true for this particle and for this particle, any particle, they're always in antiphase. So these points are very important. If I look at this particle, if I look at this point, this one is the node, all the particles in this loop and all the particles in this loop, they are in antiphase, means they have phase difference of 180 degrees. For the second part, we need to determine the speed of a progressive wave along the string. But for this question, it is given to us the distance between point A and B. This is equal to 0.80. So L is given to us. So L is equal to 0.80 meters. And L in this case, this is equal to 2 lambda. Because this is one wavelength and this is another one. So 2 lambda is equal to 0.80. So lambda simply is equal to 0.40 meters. And time period is also given to us. Time period is equal to 0.016 seconds. And question is asking us to calculate speed. So speed simply is equal to lambda over time period. Lambda is 0.40 and time period is 0.16 seconds. So the final answer in this case is 25 meters per second, and this is speed of progressive wave. For part C, it is given to us a beam of vertically polarized light of intensity I naught is incident normally on a polarizing filter that has its transmission axis at 30 degrees to the vertical as shown in figure 5.2. So as you can see, this angle with vertical is 30 degrees. It is also given to us the transmitted light from the first polarizing filter has intensity I1. This light is then incident normally on a second polarizing filter that has its transmission axis at 90 degrees to the vertical. The transmitted light from the second filter has intensity I2. First of all, for part C1, we need to calculate ratio between I1 and I0. So this question is simply about Malice's law. So first of all, let's try to understand a little bit about Malice's law. According to Malice's law, I transmitted. So we can say I transmitted. So this is I transmitted. I transmitted is equal to I incident. So this is intensity of incident light time cos square theta. And theta is the angle between two polarizing filters. Or you can say one polarized light and the polarizing filter. So in this case, we have vertically polarized light. So we have vertically polarized light, and angle with vertical means with this vertical and this polarizing filter, the angle between transmission axis. So we can say angle between transmission axis. So we can say transmission axis. So in this case, we will say transmission axis. Transmission axis. So polarized light. So this means polarized light. This is the angle between two transmission axes. So we can say this is polarized light. Angle between polarized light and transmission axis. And that angle in this case is given, that is equal to 30 degrees. So simply in this case, this is transmitted. So we can say I1. This one has to be equal to I0 cos square of this angle. That is 30 degrees. So this is the angle between two transmission axes. And so this is 30 degrees. Simply we need to find out I1 over I0. So we have to take cos square of 30 degrees. If we take this one, our final answer will be 0.75. So this is what we need to do for part 1. For the second part, we need to find the ratio between I2 and I0. So we will start from I1 first of all. So first of all, we will look at this part. This part we will look first of all, and then we will go to the second part. So this will be our second part. So we will divide into two parts. So we will say this is first part and this one will be the second part. If you look at first part, we have already done that I1, this is equal to I0 cosine square of 30 degrees. And we have already found that I1 is equal to I0 and cosine square of 30 degrees, this is equal to 0.75. So simply we can write down in this case I1 is equal to this value. And now we can go to the second part, this part. So in this case our incident is I1 and transmitted is I2. So we can again use Malice's law. We can say I2 will be equal to I1 and angle. This angle with vertical is 30 degrees and angle of this transmission axis with vertical vertical is 90. So the angle between these two transmission axes, this is equal to 60 degrees. So we will be writing here the angle between these two transmission axes is equal to 60 degrees, because angle of this one with vertical is 30 degrees and angle of this one with vertical is 90. So the difference between these two angle of transmission axis, that is equal to 60 degrees. So we can write down in this case I2, and this is equal to I1, and now we will replace I1 with this. So we will replace this. So we can write down this is I naught 0.75 time we have cosine square of 60 degrees. Now if we solve this one, we can write down I2 by I naught. This is equal to 0.75 times we have cosine square of 60 degrees. So if we solve this one, our final answer will be 0.19. And this is how you can approach this type of problems. So the final answer for this one is 0.19. Then that's all for today's lesson. I hope you have better understanding of these questions, and also you have improved your conceptual understanding of physics. If you found this video helpful, then please like and subscribe. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on electricity and radioactivity from October-November 2022, paper 2, variant 2. In the last two videos, we have discussed from question number 1 to question number 5, and for the solution of those questions, you can go to the channel and you can find the solution. Today's video, we will start from question number 6, and we will discuss question number 6 and question number 7. And this is the last video on this paper. Let's study together. Let's improve together. For question number 6, part A, we need to define electric potential difference. And electric potential difference simply is equal to energy transferred. Energy transfer means the potential difference. We can say this is equal to energy transferred per unit charge. Energy transferred per unit charge. So this is how we can define potential difference. And the better way and the precise way to define electric potential difference is we need to talk about the forms of energy. In electric potential difference, we have to write down electrical energy to other forms of energy per unit charge, to other forms of energy per unit charge. So this is how we can define electric potential difference. And now this is what you need to write down for the answer of this question. So let me show you the answer, how you can write down the answer. So this is how you can write the answer for this question. You can say energy transfer per unit charge from electrical to other forms. So you will get 1 mark. For part B, it is given to us a battery is connected to two resistors X and Y as shown in figure 6.1. The resistance of resistor X is greater than the resistance of resistor Y. We need to state and explain which resistor dissipates more power. And for power, we need to understand power is equal to I square times R. So if I is greater, it means power will be greater. If R is greater, power will be greater. Now, first of all, let's look at current. If you look at current passing through these two resistors, current is the same, because these two resistors are connected in series. So first point, simply you can write down same current passing through X and same current passing through Y. Simply you can say same current in X and same current in resistor Y. So this is one point you can write down. And the second point, simply you can copy this formula. You can say as P is equal to I square times R. So this can be 1 point. And the third point, you can say power dissipated in X will be greater because Rx, this one is greater than Ry. So more power dissipated in X. So we can say X dissipates more power. So X dissipates more power. So X dissipates more power. So this is how you can write down your answer. So quite straightforward question, but you need to understand how to write down these steps. This question has 3 marks, so you need to write down at least 3 points. For part C, it is given to us a battery of electromotive force 9 volts and internal resistance small r is connected to two resistors P and Q as shown in figure 6.2. A total charge of 650 coulombs moves through resistor P in a time interval of 540 seconds. During this time, the resistor P dissipates 4800 joules of energy. The current in resistor Q is 4.5 amps. Assume that EMF of the battery remains constant, and we need to calculate for part 1 current in resistor P. Current in resistor P. Current is not simply rate of flow of charge. The better way to define current is the amount of charge passing through a point per unit time. Amount of charge passing through a point per unit time. So in this case, resistor you can treat, it is given to you amount of charge passing through resistor P in given time. So you can calculate current. So simply we can say I will be equal to the amount of charge passing through resistor P in given time. So this is delta Q over delta T. So delta Q is given to us, that is 650 coulombs, and current in time in this case is given to us, mean this amount of charge passing through resistor P in time 540 seconds. So we can calculate value of current, that is equal to 1/2 amps up to 2 SF. We have to use 2 SF because the given data, it has 2 SF. So we have to consider least number of SF in given data. So the answer for this question is 1.2. For the second part, we need to calculate the potential difference across resistor P. But energy dissipated in resistor P is given to us, that is equal to 4800 joules. It simply means that this much electrical energy has been converted into thermal energy when Q equal to 650 coulombs passes through resistor. Now we have these things and we need to calculate potential difference. So potential difference simply is equal to work done per unit charge. So in this case, we have total amount of work done divided by total charge passing through resistor. So we will divide by Q. So in this case, we have W, total energy dissipated, that is equal to 4800 joules, and Q is 650 coulombs. So the value of PD, potential difference, we can calculate. That one will be equal to 7.4 volts up to 2 SF. So this one is our final answer. So this is how you can calculate potential difference. It simply means that when this much charge will pass through resistor P, this amount of electrical energy, this will be converted into thermal energy. So this is how you can calculate potential difference across any resistor. For the next part, we need to calculate internal resistance of the battery. And we have already calculated current passing through this resistor, that was equal to 1.2 amps. So now we can find out current entering the battery and current leaving the battery. Current entering the battery will be equal to sum of these two currents. So we can simply write down this will be 5.7 amps, and it's better to write down this here as well, because if you write down this step and if your final answer is wrong, still you will get 1 mark for calculating total current in the circuit. So we can say here we have 1.2 amps plus we have 4.5 amps, and total current in the circuit is 5.7 amps. And also current leaving the battery has to be the same, so this is also 5.7 amps. Now we need to calculate value of this resistance, and we have potential difference across this resistor. So if we connect our voltmeter here, let's say this is voltmeter V1, and reading on this one will be 7.4 volts, and we can use this loop now and we can calculate value of R. So we will be using this loop. So we will take this loop. Now simply you need to apply Kirchhoff's second law. I will start from this point. If I go from negative terminal to positive terminal, potential will increase. So the change in potential is positive. So I will write down 9 here. And then when we cross this one, we go in direction of current. It means that potential will drop. So the drop in potential will be 7.4. And now we go in direction of current. So potential also here will drop. So we go in direction of current, so potential will drop. So we will simply write down this is I times R, and that one has to be equal to 0, because according to Kirchhoff's second law, delta V in any loop is equal to 0. So that's the reason we have written this is equal to 0. Now we can rearrange. We can say 9, this one will be equal to 7.4 plus I times R. I times R. So we can rewrite this one. And value of current passing through this resistor is 5.7. So we can replace I with 5.7, and here we have R. So we need to calculate R. So simply you can write down 9 minus 7.4 divided by 5.7, and this is value of R. So R in this case will be equal to 0.28 ohms, and this is our final answer, and this is how you can calculate. A beautiful way to understand how to approach this type of problem. So simply you need to take this loop, because we have potential difference. You can also take this outer loop, result will be the same, but for this one we don't have the resistance. For question number 7, part A, we need to describe the structure of an atom of uranium-238. Structure means we need to talk about protons, neutrons, and electrons. So first of all, let's try to write down the number of protons. This atom has number of protons. So this is number of protons. So simply we can say it has 92 protons. And number of protons in an atom is also equal to number of electrons. So we can say this atom also has 92 electrons. So we can say number of electrons also equal to 92. Now we need to find out number of neutrons. Number of neutrons. And number of neutrons simply is equal to mass number 238 minus atomic number 92. And the final answer in this case we will get, that is equal to 146 neutrons. So this is what you need to write down for the structure of uranium-238 atom. For part B, it is given to us the decay of uranium-238 is shown by the equation. For nucleus X, we need to calculate the ratio in coulombs per kilogram of charge over mass. Means we need to calculate charge over mass ratio, and our answer has to be in coulombs per kilogram. So first of all, let's try to understand this nucleus X. Here we have proton number, that is 92, and here we have 90. So the proton number of this nucleus is 2. And if you look at the mass number, the mass number of this one has to be 4. So simply this is alpha particle, or simply you can say this is helium nucleus. So we can write down the charge on this nucleus. First of all, charge will be equal to plus 2 times E, and E is the charge on single electron. And the mass of this one, this has 2 protons and this one has 2 neutrons. So we can say the mass of this one, so we can write down mass will be equal to 4U, and 1U is equal to 1.66 times 10 to negative 27 kgs, and value of 1 AMU you can find in the data. If you can remember, it's wonderful. Otherwise you can find on the second page of this exam paper. So this is value of 1 Joule, and we can also write down this charge. We can say 2 times, and the charge on single electron is 1.6 times 10 to negative 19 coulombs. Now simply we need to divide these two quantities and we can calculate charge to mass ratio. So we can simply write down charge over mass. We need to find the ratio between these two quantities. We have charge that is equal to 2 times 1.6 times 10 to negative 19 coulombs, and we need to divide by mass. Mass is 4 times 1.66 times 10 to negative 27, or minus 7 you can say. If we do calculations, our final answer will be 4.8 times 10 to 7 coulombs per kilogram, and this is our final answer up to 2 SF. So this is 4.8 times 10 to 7. So this is how you can approach these problems. The best way to answer problems is read question carefully and try to answer step by step. So in this way you can develop your problem solving skills. Don't just try to use quick method. Try to understand at the beginning step by step, and then you can speed up yourself. So this is a best way to answer this type of problems. And also in your exam, please write down all the steps. Don't use shortcuts. You will lose marks. So always write down all the steps. For part C, it is given to us two particles P and Q, each consist of three quarks. These quarks are up or down quarks. Particle P has no overall charge, means it is neutral, and particle Q has an overall charge of +2e, where E is the elementary charge. State the quark composition of particle P and particle Q. Particle P, as it consists of up and down quarks and it has no charge, so simply it means that this is neutron. So it has the same quark composition as quark composition of neutron. So this is simply up, down and down quark, mean UDD. So this is how you can write out. If we go to particle Q, the charge on this one is +2e. So the quark composition of this one can be 3 up quarks. So it can consist of 3 up quarks. So we can check this quark composition now, means we can check the total charge on particle Q. So we can say the total charge on particle Q will be equal to +2 by 3e plus 2 by 3e plus 2 by 3e. So in this case, total charge is equal to +2e. It means this is quark composition of particle Q and this is quark composition of particle P. It consists of 1 up quark and 2 down quark, and particle Q, it consists of 3 up quarks. That's all for today's video and also for this paper. If you find these videos helpful, please like and subscribe because your encouragement is very important to make more videos. See you in next video.